All right, welcome to our explainer, where today we're going to unravel a chemical family story. We're going to see how three groups of chemicals you see all the time in your hand sanitizer, the vinegar in your kitchen, even in perfumes, are actually all related. They're part of the same family. So let's piece their story together.
Okay, let's start with something you've probably used about 1,000,000 times, especially over the last few years. Hand sanitizer. I mean, this stuff is everywhere, right? In our bags, on our desks. Well, this simple bottle is actually our first clue in a really cool chemical mystery.
So you know it works, you know it cleans your hands. But what's actually in there doing the work? What's the secret ingredient, the molecule that does all the heavy lifting to get rid of germs? Let's find out.
Okay, drum roll please. The secret ingredient is an alcohol. But here's the thing. In chemistry, alcohol isn't just one specific substance. Nope, it's the name for an entire family of molecules. So what exactly makes a molecule part of this alcohol family?
Every chemical family has a kind of signature, a special feature that says, hey, I belong to this group. For alcohols, that signature is the hydroxyl group. You see it written as -OH. It's just one oxygen atom and one hydrogen atom, but this little piece is everything. It's what gives an alcohol its identity and its properties. Think of it like their chemical family crest.
And here we go. You can see that signature right here on a real molecule. This is propanol. You've got the main part, which is just a chain of carbon and hydrogen atoms. But look, right there on the end, that's our all-important OH group. That's the flag that tells us, yep, this is an alcohol.
And you know what? Here's the best part. Naming these things is super easy. Seriously, you just figure out the name of the main carbon chain, and then you just tack on the letters OL at the end. It's a simple little rule that makes spotting them a piece of cake.
You can see that pattern so clearly right here. If there's one carbon, it's methanol. Two carbons, that's ethanol. That's the type of alcohol you find in alcoholic drinks. Three carbons, the one we just saw, is propanol. And 4 is butanol. See? The first part of the name tells you how big it is, and that all ending tells you what family it's in. Simple.
So, we've met the first character in our chemical family story. But what happens when that character changes? This is where the plot really starts to thicken. Because alcohols don't stay the same forever. They can transform, especially when they react with oxygen.
When an alcohol gets oxidized, it's not just a small change, it's a total identity switch. It becomes a member of a totally different family, a carboxylic acid. Oxidation is the chemical bridge that connects these two branches of the family.
Now, to meet this new family, let's grab another thing from the kitchen. Vinegar. You know that sharp, kind of sour smell and taste? That comes from its main ingredient, which is called ethanoic acid. And that is a perfect example of a carboxylic acid.
Just like alcohols had their OH signature, carboxylic acids have their own family crest. It's called the carboxyl group, or -COOH. And this functional group is what gives them all their defining acidic properties. It's the reason the ethanoic acid in vinegar acts the way it does.
And look at how this all connects. The naming pattern here ends in oic acid. But check this out. Ethanol, our 2-carbon alcohol, oxidizes to become ethanoic acid, the 2-carbon acid. Propanol becomes propanoic acid. The family name changes, but the carbon count, that first part of the name, it stays exactly the same. How cool is that?
Okay, so we've met the alcohols and we've met the acids they can turn into. Now it's time for the third and final act, creating esters. And esters are famous for one thing more than anything else, their smells. These are the molecules that give us the sweet, fruity scents of things like pineapples, pears, and all sorts of perfumes. So how do we make these amazing smelling chemicals? Well, we bring our two families together. Making an ester is kind of like a chemical wedding between an alcohol and a carboxylic acid. They are the two parent molecules. Let's stick with the examples we've been using. From the alcohol family, we'll take our ethanol. And from the acid family, we'll take our ethanoic acid. Now, let's see what happens when these two react.
This reaction has a fancy name, esterification. Now watch this closely. The entire OH group from the carboxylic acid and just the single H from the alcohol's hydroxyl group, they break off and join up. What's an H and an OH? H2O, water. They literally pop off to form a water molecule. And the two big pieces that are left behind, they snap together, forming a new bond called an ester linkage. And this brand new molecule, that's our ester.
Okay, so we made an ester. That's awesome. But what on earth do we call it? Now, naming them might look a bit tricky at first, but trust me, there's a really simple logic to it. The name literally tells you the story of how it was made.
An ester's name always has two parts. The first part comes from the alcohol. You take the alcohol's name, like ethanol, and you change the ending to IL. So ethanol becomes ethyl. The second part comes from the acid. You take its name, like ethanoic acid, and change that ending to OAte. So ethanoic acid becomes ethanoate. You just put them together, and what do you get? Ethyl ethanoate. The name tells you its parents.
Whew, we have covered a lot of ground here, right? We've gone from hand sanitizer all the way to perfumes. So now let's just pull back for a second and look at the big picture, our complete chemical family tree, and see how this all clicks into place.
And there it is, the whole story in one shot. We start with our alcohols. Through oxidation, they transform into carboxylic acids. Then, if you react an alcohol with a carboxylic acid, they join together in esterification to create our third family, the esters. See, it's not three random topics you have to memorize. It's three parts of the same family, all connected by simple, predictable reactions.
So, if there's one thing you really take away from all this, it's that chemistry isn't just a list of separate facts to memorize. It's one big interconnected story. We just saw how three different chemical families are linked together. And when you start seeing those links, that's when you really start to get chemistry.
And that kind of leaves us with one last thought. Now that you know this chemical family story, what other connections are hiding in plain sight all around you? In your kitchen, your bathroom, the garden? The world is full of this stuff. So keep looking and keep asking questions. Thanks for joining me.